Imagine clicking a checkout button on a massive e-commerce site, and the data saves to the database so incredibly fast that you actually think the site is broken.
Right, like nothing happened.
Exactly. There are no loading spinners, no janky screen flashes, no waiting. You just click and it's done.
Yeah, that instant feedback.
So today, welcome to the deep dive. We are tearing apart Next.js 16 to find out how Vercel is, well, basically making the traditional API obsolete.
Which is a huge claim, but yeah.
It really is. And for you listening, whether you're, heading into a software architecture meeting within minutes, or you just want to know why modern web applications suddenly feel as snappy as native desktop software, we are unpacking the raw mechanics behind this release.
Yeah, we're really getting into the weeds today. We've got the official documentation, the showcase material from the Next.js website.
Right, and our mission here is to understand exactly what Next.js is, why the world's biggest brands rely on it, and how it is fundamentally blurring the lines between front-end and back-end web development.
Or, completely erasing those lines in some cases.
Seriously, because building for the web today isn't just about making a site look pretty anymore. It's about sheer speed, efficiency, and delivering just a flawless user experience. The documentation says Next.js is the framework of choice when it matters.
When it matters. I love that phrasing.
Okay, let's unpack this. If we think about building a traditional React application, it's essentially like ordering a house, right?
Right.
But receiving a massive, heavy crate of premium lumber, drywall, and nails just dumped onto your empty lot.
Yeah, giant pile of raw materials.
Exactly. And your browser, the poor client, has to frantically assemble all those materials on site before you can even open the front door.
Which takes a lot of time and energy.
Right. But Next.js, by contrast, it's like ordering a fully prefabricated house. It just drops onto the lot with the plumbing already connected to the city grid, the lights are on, the climate control is set to 72 degrees, you just walk right in.
That is, honestly, it's a really compelling way to look at it because it highlights the fundamental architectural shift here. Well, React is just the view layer, right? It's the lumber. It gives you the raw components for building a user interface. But Next.js is the overarching framework that surrounds those components with a full production-ready infrastructure.
Okay, so it builds the house for you.
Exactly. But the crucial difference with version 16 isn't just that it pre-builds the house. It's really about where that building takes place.
Okay, where does it take place?
On the server. The core philosophy here is offloading all that computational heavy lifting away from the fragile, unpredictable environment of the user's browser.
Right, because you never know what the user is on.
Exactly. They could be on a smartphone with a weak processor or, a spotty 5G connection. Next.js moves all that work back to highly optimized, centralized servers.
Which brings us straight into the mechanics of React Server components, because this feels like the bedrock of what they are doing here.
It absolutely is.
Because in a traditional single-page application, if you want a complex interactive data table on your screen, you have to send the actual JavaScript instructions for that table over the wire, right?
Right, the whole chunk of code.
The user's phone downloads it, parses it, and executes it just to figure out what to draw on the screen.
And that parsing and execution time, that is exactly what blocks the main thread. That's what causes that sluggish, jittery performance on mobile.
So how do server components fix that?
Well, with React Server Components, Next.js completely flips that model. The server executes the component logic, it crunches the data, renders the final structural HTML, and then it just ships that lightweight result to the client.
Oh, wow. So no JavaScript for that component.
Zero. You're adding highly complex UI component to a page without adding a single kilobyte to the client-side JavaScript bundle.
That's wild. So the phone's processor does way less work, which means the battery lasts longer and the site just feels faster.
Exactly.
But here is where the narrative connects for me, because if the component is living on the server, that completely changes how we handle data fetching.
Or changes everything.
Because traditionally, the component loads on the client, realizes it needs data, and then it fires off an asynchronous request to an API, which creates that dreaded waterfall effect of loading spinners, spinner after spinner.
Yeah, the classic cascade of loading states. And that is precisely the bottleneck Next.js is bypassing now.
How?
Because the React component is now executing on the server right next to your database.
Right.
So you can make the component itself asynchronous.
Wait, you can just make a UI component async?
Yeah. You literally just write an await statement inside your React component to query your database. It fetches the data natively, formats it, injects it into the HTML, and sends down the finished view.
No intermediate API calls.
None. No API calls over the public internet. No client-side use effect hooks managing, true or false loading states. It's all done before it even leaves the server.
Okay, fetching data on the server makes total sense. We're reading data fast. But what happens when the user needs to write data back?
Right, mutations.
Yeah, like a user updates their profile or they submit a comment. Do we still need to build a whole separate REST or GraphQL API to catch that incoming mutation?
You would think so, but no.
Because the documentation talks about server actions, and they literally claim developers can skip the API entirely. They say you just call a function. That sounds like black magic to me. How is it actually doing that?
It really does feel like magic, but mechanically, it's just a brilliant abstraction.
Right.
When you define a server action in your code, Next.js actually analyzes that function during the build process.
Okay.
And under the hood, the framework automatically provisions a secure hidden post endpoint.
Oh, so it makes the API for you.
Exactly. So when your front-end button triggers that function, Next.js handles all the network serialization. It sends the payload to its own auto-generated endpoint, executes your secure server code like a database commit, and then it automatically invalidates the cache to update the UI with the fresh data.
That's insane. So you don't write the API endpoint at all?
No, you don't handle the routing, and you don't even manage the state reconciliation to show the new data. Next.js does it all in a single network round trip.
Okay, here's where it gets really interesting. And I have to push back here because this is setting off some major alarm bells for me.
Okay, let's hear it.
If we are rendering the UI on the server and fetching all the data on the server and handling mutations with hidden POST requests, aren't we just reinventing 1998?
Ah, the 90s web argument.
Right, because isn't this exactly how old school PHP or ASP sites were built? You click a button and you have to stare at a blank white screen while you wait for the server to process the action and generate an entirely new page from scratch.
What's fascinating here is that is the classic architectural trap of traditional server-side rendering. And honestly, if Next.js stopped there, you would be absolutely right. We'd be right back in the 90s.
So how do they avoid the white screen of death?
They circumvent that synchronous bottleneck using something called dynamic HTML streaming, which they pair with React Suspense.
Okay, streaming. Think of it like this. Tell me if this analogy works. Traditional server rendering is like sitting at a restaurant where the chef refuses to bring anything to your table until a massive 5-course meal is entirely plated.
You're right. You just sit there with an empty table.
Exactly. You sit there with nothing. But streaming with React Suspense is more like a tapas restaurant. The server instantly brings out the drinks and the layout of the table, like your navigation bar, your sidebar, your footer. That happens in milliseconds.
Yep.
Then, as the heavier dishes, the complex database queries finish cooking, the server literally streams them onto your table in real time, right into the empty slots.
That analogy hits the underlying mechanism perfectly. The server doesn't wait for the slowest data query to finish before sending the HTTP response.
It just sends what it has.
Exactly. It opens the connection and flushes the initial shell of the UI to the browser immediately. So the user sees a fully constructed page shell instantly. Then, as those asynchronous server components resolve their data, Next.js streams the HTML chunks over that exact same open connection. It swaps out the suspense fallbacks, the loading skeletons, with the final content.
So you get the raw computational power of the server, but the smooth, non-blocking, app-like transition of a modern client-side router.
Best of both worlds, really.
So that handles the dynamic real-time data. But what about scale?
Scale.
Yeah, because if you have millions of people hitting a site, you can't dynamically render a page for every single visitor, no matter how fast your streaming is, right? Your servers would just melt.
Right. And that's where the documentation highlights incremental static regeneration, or ISR.
ISR.
Yeah, ISR is basically their caching masterclass. It allows you to utilize a stale while revalidate strategy on a strict per-page level.
What does that mean in practice?
Well, imagine a big media site. When the first user requests an article, the server generates it and caches that static HTML at the edge, globally.
Okay.
So the next million users get that static file instantly.
Because it's just a flat file at that point.
Exactly. But let's say an editor goes in and fixes a typo. With ISR, you can configure the cache to revalidate in the background. So the next user who requests the page still instantly gets the cached version.
The one with the typo?
Yes, the stale one. But that request silently triggers Next.js to quietly rebuild the page on the server in the background. Once the new build is ready, It seamlessly replaces the old cache.
That is the holy grail. You get the instant time to first byte of a static site generator, but the living, breathing data of a dynamic server application.
It really is.
Oh, and before we move off the server stuff entirely, we have to talk about middleware. I love this concept. If ISR is the cache, middleware is like the bouncer at the club.
That is a great way to put it. That bouncer is operating at the absolute outer edge of the network.
Right.
Middleware allows you to intercept an incoming HTTP request before it even reaches your core server logic. You can inspect the request headers, check an authentication token, execute routing rules.
So if a user isn't logged in,
the middleware bounces them to the login screen with zero latency. It entirely bypasses your application's rendering cycle.
that saves so much server load.
Oh, totally. It's also utilized heavily for internationalization, like detecting the user's locale and instantly routing them to the correct language path before the page even attempts to load.
Okay, so let me just recap this. We have server components, streaming, hidden API generation with server actions, ISR background caching, and edge middleware.
It's a lot.
It is a staggering amount of infrastructure, which raises a massive question for me. How does the framework handle this locally?
What do you mean?
Like, if I'm a developer trying to build all this on my laptop, how does the development server not just melt my CCU and grind to an absolute halt?
Well, if they were still relying on traditional JavaScript bundlers and the standard Node.js runtime, it absolutely would melt your laptop. The sheer volume of file parsing and dependency resolution required for an architecture this complex, it would make local development agonizing, which is exactly why Vercel fundamentally ripped out the old engine and replaced it.
What did they replace it with?
They rebuilt their core compiler infrastructure using Rust.
Rust. This is a huge talking point in the ecosystem right now. The documentation says they've built TurboPack and the speedy web compiler SWC on a Rust foundation.
Yeah, the shift to Rust was really an architectural necessity. You have to remember, JavaScript runs in a single-threaded runtime.
Right.
And it has a garbage collector that can randomly pause execution just to clean up memory.
Yeah.
It is simply not designed for heavy, multi-threaded file system operations.
But Rust is.
Oh, yeah. Rust is a low-level, statically typed systems language. It compiles directly to machine code. It offers incredibly aggressive memory safety, and it doesn't have a garbage collector.
Wow.
So by rewriting their bundler, TurboPack, and their compiler, SWC, in Rust, Next.js can analyze the dependency graph of a massive enterprise application in fractions of a millisecond.
Okay, so to take my earlier car analogy further, if traditional JavaScript development tools are like a reliable but kind of chugging gasoline engine, dropping in TurboPack and SWC is like ripping that gas engine out and dropping in a state-of-the-art electric motor, you don't have to wait for the RPMs to burn up. You get instant maximum torque.
That's exactly how it feels to use it.
The second you hit save in your code editor, the Rust compiler instantly resolves the delta and your browser updates in milliseconds.
And we connect this to the bigger picture. That compilation speed fundamentally alters the economics of software development.
Really? Just from a faster save time?
Absolutely. It's not just about saving a developer 3 seconds on a page reload. When a developer loses their train of thought waiting for a build step, context switching destroys productivity.
Oh, for sure. You pick up your phone, you check a message, you've lost the zone.
Right. So when you give an engineering team an environment that reacts instantaneously, they iterate faster, they experiment more aggressively, and the overall quality of the code base just skyrockets.
And I guess that developer velocity translates directly to the end user, right? Because Next.js has all these built-in optimizations for images, fonts, and scripts.
Yes, the core web vitals.
Right. We know how critical core web vitals are. Google will literally throttle your search ranking if your site performs poorly. And the docs say Next.js automatically prevents DOM repaints and thread blocking by handling image sizing and font loading under the hood.
And this ties right back to Rust. Because the compiler is so fast, developers can actually afford to utilize these complex optimizations during development without slowing down their workflow.
Ah, I see.
Yeah, Next.js dynamically manages image compression based on the requesting device's viewport, and it injects CSS size adjust properties to ensure custom fonts don't cause layout shifts when they finally load. The framework is abstracting away the most tedious, error-prone aspects of performance tuning.
Okay, let's step back for a second. The mechanics make sense. Server components reduce the payload. Rust compilers provide the torque. Screaming avoids the 90s blank screen. The theory is airtight.
It's very solid.
But theory doesn't always survive contact with the actual internet. If I'm an architect evaluating this, I need to know if this actually holds up under the crushing weight of real-world enterprise traffic. Who is actually trusting their bottom line to this architecture?
Well, the adoption metrics in the showcase material are pretty definitive. We are looking at companies where infrastructure failure is measured in millions of dollars.
Like who?
Audible, Sonos, Dice, Notion, Nike Product Hunt, The Washington Post.
Wow, The Washington Post and Nike. Those are phenomenal examples because they are constantly updating inventory, publishing breaking news, and serving high-resolution media.
Exactly. These are platforms handling incredibly complex state, massive asset delivery, and ruthless concurrent user loads.
And the specific metrics reported by engineers are staggering. There's a quote here from Charlton Roberts from Frame.io's product engineering team. He reported that by leveraging Next.js, their user interface responds to input within 100 milliseconds, and their animations maintain a flawless 60 frames per second.
Yeah, that 100 millisecond threshold is critical. In human-computer interaction studies, anything under 100 milliseconds is perceived by the human brain as instantaneous.
Really? Just 100 milliseconds?
Yep. That is the barrier you have to break to make a web application feel like natively compiled software. And achieving a locked 60 frames per second means the browser's main thread isn't being hijacked by massive JavaScript payloads parsing in the background.
Which goes right back to the server-rendered architecture we talked about.
Exactly.
There's another data point here from a senior front-end software engineer who noted their team consistently hits a cumulative layout shift, or CLS, of 0.09 or lower.
That is incredibly impressive.
Right. For anyone who has spent days agonizing over DOM elements, jumping around during page load, hitting sub-0.1 at enterprise scale is basically the gold standard.
It really is.
And it's not just the enterprise behemoths either. Daniel Lopes, a front-end developer, called Next.js a game changer for agency work. He specifically noted how the built-in performance features radically accelerate team collaboration and delivery timelines.
Which highlights the scalability of the framework itself, provides the architectural rigor required by a giant like Nike, but also the developer ergonomics and rapid iteration speed demanded by a lean, fast-moving digital agency.
All right, I have to play devil's advocate here for a second.
Go for it.
So what does this all mean? Because we are looking at a framework created by Vercel. And Vercel is a highly profitable front-end cloud hosting platform.
Yes, they are.
They offer this incredibly slick ecosystem, e-commerce, boilerplates, AI starter kits, SaaS templates, all designed to deploy onto Vercel's infrastructure with a single click. So if I am a CTO and I choose to build my entire company's product on Next.js utilizing server actions, edge middleware, and ISR, am I essentially walking into a trap? Am I locking my entire architecture into Vercel's paid cloud ecosystem?
That is the most critical architectural question to ask. And the documentation addresses the licensing very directly. Next.js is explicitly categorized as open source software. The repository is hosted on GitHub. It operates under a permissive MIT license. The framework itself is completely decoupled from the hosting environment.
Sure, it's open source on paper. I can pull the code. But if all the advanced features, like the edge routing for middleware or the background caching for ISR, require Vercel's proprietary infrastructure to actually run performantly, isn't that a backdoor lock? Can I actually run this on my own AWS cluster?
You absolutely can. You can containerize a Next.js application using Docker and deploy it to AWS, Google Cloud, or just a bare metal server.
Really? And the features still work?
Yes. The Node.js server that Next.js builds handles the ISR caching and the server actions independently.
Okay, that's good to know.
Now, does Vercel make it frictionless? Yes. Their edge network is custom built to automatically distribute those Next.js functions and caches globally without you having to configure a Kubernetes cluster or manage edge lambdas.
So you're paying for convenience.
It's exactly. Companies are choosing Next.js for the raw metrics, the sub-100 millisecond response times, and the developer velocity. They often choose Vercel's hosting for the operational convenience. But structurally, the framework does not mandate the platform.
That distinction is vital. You own the code, but you can pay for the convenience of not managing the plumbing.
Right.
So let's pull all these threads together. Looking at the scope of Next.js 16, it is abundantly clear that we are not just talking about a simple library update here. The release notes proudly claim it brings the power of full stack to the front end. And based on the mechanics we've explored today, that really isn't marketing hyperbole.
No, it's a fundamental realignment of the development stack. By natively integrating data fetching, server-side execution, routing, and background caching all into the React component tree, Next.js is eliminating massive layers of architectural friction. friction that previously required dedicated back-end teams to manage.
So, for you listening, whether you're about to walk into a planning session to debate your next tech stack, or you're simply scrolling through a modern platform like Notion and marveling at how a web browser can possibly feel that fast and fluid, you now understand the engine making it happen.
Yeah, you see behind the curtain.
You know how Rust compilers are feeding lightweight server-rendered HTML streams directly to your device, bypassing the client-side bloat entirely?
It really represents a maturation of the web.
Yeah.
We are finally moving past the binary choice of either building a fast, static document or a heavy dynamic application. Next.js proves you can engineer both simultaneously.
It is a brilliant piece of engineering, but there is one specific mechanical shift we discussed today that I just cannot stop thinking about, and I want to leave you with this final provocative thought.
Oh, here we go.
We broke down how server actions operate, how the framework automatically wires up secure hidden endpoints, allowing front-end developers to query databases and execute server-side mutations directly from their UI components, entirely skipping the traditional API layer.
Right, skipping the API.
So, if front-end developers armed with Next.js can now handle authentication routing, data fetching, database mutations, and cache invalidation without ever writing a REST endpoint, what exactly does the future hold for the traditional back-end developer?
That is a very good question.
As this server-driven front-end architecture matures and eats more of the stack, are we rapidly heading toward a web where the dividing line between the front-end and the back-end simply ceases to exist? It really makes you wonder.
It does.
We started today by comparing traditional web development to receiving a pile of raw lumber and Next.js to receiving a prefabricated house. But looking at the trajectory of these tools, it seems like developers aren't just ordering the house anymore. They are being handed the tools to entirely redefine what it means to be the architect.